Hi people, and welcome to this complete tutorial for beginners in Revit. This video takes almost 2 hours and 15. It's quite long, isn't it? And it's divided in 7 parts. If you prefer to watch the same tutorial split in shorter videos, that's fine. Just click on the card that is appearing above. I know some people prefer that way, while for others it's just fine, everything packed in one. So that's according to your preference. Also, this is important, in the description of the video you can find a full list of contents, so if there is a specific topic you want to watch, just click on the time next to the title. This version is Revit 2020, but don't worry if you have a different one, because the versions don't differ a lot from each other, and also my way of conducting will take that into consideration. At the end of this video, you will get the knowledge to start making your own projects. And even this tutorial is more focused on the architecture tab of the ribbon, I still recommend it if you are a structural engineer, because I will cover the fundamentals of the software here, and once you have practice, it will be easier to learn the commands at the structure, steel and other tabs. For now, let's start, and I hope you will enjoy it. Let's make a brief introduction of the program. Revit is a building information modeling software for project documentation. It's different from AutoCAD, which is a pure general CAD, computer-aided design. Revit provides us the possibility of making complete projects in architecture and engineering subjects. One of its main characteristics is, when modeling a building, the program automatically generates different views. Look at this example. In this file, you have floor plans, elevations, or sections. Suppose I'm working on this floor plan and I add a new door. The view East Elevation, which is the view from this side, automatically updates with the new door there. Unlike AutoCAD, in Revit we don't draw lines, curves or other simple objects. The elements we insert in our drawings are more complex. Most of them are real parts of a building. Along there are some 2D elements like text, dimension lines, or scheduled tables. Models and families. Every time I start Revit, this layout appears where I can choose between 2 types of files to work with. Basically, if I want to make a project on Revit, I need to create a new model. On the other hand, families are the elements used on projects. Let's look at this in detail. I'm going to open the example of the model that I showed to you previously. This one. This is the main display of Revit. The main window is the working area where we draw our projects. On the top is located the ribbon. There you can find all the tools which will help you to complete your drawings. It's divided in different categories, organized by tabs: architectural, structures, steel, and so on. At the left side there are located these 2 windows by default, but they are possible to display differently or to resize if you want. The one below is the project browser. It's where I choose what to see on the main window. It's organized by categories, and I can minimize or maximize them clicking here. In Views, I can switch to the different views of the project: floor plans, 3D views, elevations or sections. To open a view, I double-click on the one I want, and a new tab appears on the project. In this case, the floor plan level 1. Now let's look to a 3D view. An elevation view would be like this, and the section. Aside from views, there are also schedule tables, sheets for printing purposes, among other features. Basically, you can make a full project just in one file. Now I am going to open a sample family template. Let's choose this one, Architectural. As you see, what I have here is a furniture element to use in an architectural project. The display in a family file is pretty the same as in a model file. On the project browser, you can still switch from different views. Now let's look at the Properties window, back in our sample project. Basically, it shows the properties of the current element active. If I click on this furniture, you can see the information of that element. Here you can find geometrical details, as well as information about its location on the project. As every element here, it was created as a family. Also, the prompts that appear on the properties change depending on the kind of element active. By the way, if I don't have any element selected, the property shows the information of the current tab. How to use the mouse in the workspace. First of all, it's important to have in mind that you should use a mouse with a scroll wheel. It's going to be very hard to work in Revit with the touchpad, as we need to zoom all the time, select objects, or move the workspace. If you know AutoCAD, the way to use the mouse is very similar here, but there are some slight differences. Mouse wheel. With the mouse wheel, I can zoom in or zoom out the workspace. To move the workspace area, press and hold the wheel, and now you can move around. Left button. Select Elements and Selection Area. Clicking with the left button, I can select an element, which is the same as a family. To select more than one element, I can click first in one, then have to hold Ctrl to click on the second. Another option to select objects is using selection areas. And like AutoCAD, there are two kinds. If I start from the right to the left, and I need to click and hold the left button, I can select any element that I touch with the pointer. However, if I make the selection from the left to the right, I need to completely cover the elements to select them. Right button. If I click with the right button in the project window, this panel opens with several options. For example, it's possible to switch on or off the Properties panel and the browsers. As you see, the project browser is active, but there are others that I can add. In the next chapter, I will show you how to start a new project in Revit. You will learn to start drawing a floor plan and how we can manage with the different views. As soon as we click to open a new project, this window shows up on the screen. There are 4 default templates that come with the software. The difference between them is the organization of the project browser. For example, in a structural template, the tabs are specific in order to make a structural project. Of course, it's also possible to create your own templates, but that's something to learn later. In this video, I'm going to create an architectural project. Click on File, then go to New, Project, and in this tab I select Architectural Template. So we have now opened a new file as an architectural template. Now, to encourage you to start evolving in the program, In the next few minutes, you will learn how to create walls properly. I'm going to draw it in a floor plan, and then I switch to an elevation view to check out if it has the correct height and at what level it's placed. Let's open the view Floor Plan Level 1. This tab indicates which entry from the project browser is currently active. If you are not on Level 1, double-click on it there. Now I am going to create a wall. It's very simple. Click on the icon located in the Architecture tab at the ribbon. Alternatively, I can type the shortcut WA. Then click, for example, here to place the start point. And let's suppose I want to draw a horizontal line. When you try to draw it, and if you have the default Revit settings, the wall snaps automatically when I'm close to the horizontal direction. And the same applies when I want to make it vertical. To set up a specific length, just type the value that I want and press Enter. It's the same as in AutoCAD. Then the system prompts me to insert another wall connected to the first one. This time I want it vertical. And once it's done, they automatically connect to each other. Press Escape to exit the wall placing function. And look, a good thing that happens in Revit. If you don't save the project for some time, this window appears to recommend you to do it. Now let's see an effective way to draw only orthogonal walls. It's very simple. Hold the button Shift while drawing and you can see it's much faster. Okay, let's continue. I'm going to activate again the action for placing a wall, and this time I type its shortcut, which is WA. And this is important. Anytime I add a new element to the project, the ribbon switches to the Modify tab. There, the display of icons and panels is adapted for the current element. In this case, it's specified for placing walls. Now, let's look what I can do here. Draw Panel Tools. The default shape to insert a wall is a line, but you can find several there, depending on each situation. If you know how to use AutoCAD, these tools and the way they work are a bit similar to the drawing commands back there. The default option here is to draw in a line shape, and it's also the most common one. If I want a rectangular shape, I click on the icon and the result is like that. Here, if I want to type a specific length values, I need to do it after placing the walls. Also, notice that each wall is still independent. Here I click in this length to change it. Then there are also polygons, circles, arcs, or ellipses. Units. The default length units in Revit are millimeters, but it's possible to change them in project units. Go to the Manage tab. In the Settings panel, click on this icon, Project Unit. The shortcut is UN. In this window, we can edit all the units that we can use on Revit. The units are grouped by disciplines, as you can see in this tab. The common units are probably the most used ones. There you can find the length units, area, volume, and more. For example, if I switch to structural, the units are related to this discipline. Mass, force, moment, there is a big list here. Back to common. To edit length units, I click on this button and the format window appears. Now, in the first tab, I can choose from one of these types. In this project, I want to specify the units as meters. In rounding, I set the number of decimal places. I choose 2 decimals to have a precision up to the centimeters. And this is important. It applies only for dimension lines. Because when I'm sketching, the 4 decimals still appear here. In unit symbol, I decide if I want a symbol, in this case M, to appear or not. Suppress trailing 0. If I tick this option, this hides the zeros that appear at the right. Can you see? They are no longer there. Okay, let's talk again about walls. Anytime we insert a wall in the project, we draw it based on its line, which is this blue dashed line. The one set by default is the wall center line, and it's located in the center of the wall independently on the wall type and materials used. And on the Properties window, I can check out where the location line is. If we draw this example using the wall center line, the values there are the dimensions of the axis located on the center of the wall. And sometimes it's better to have the line in a different position. Now, let's look to the next example. Here, I have these walls with external dimensions. If I click on the Location Line tab, I can see these different options. I will explain to you after, but for now, I switch to Core Face Exterior. Basically, the location line is located on the external side when I draw clockwise. If I select Core Face Interior, the location line appears on the internal side when drawing the same direction. By the way, if you find this confusing, it's not a problem, because you can always press the spacebar to switch the position of the line. Looking again at the Location Line tab, you can see these options like Core and Finish Face. What exactly is that? For Revit terminology, in a simple wall, like the ones we were drawing, the core corresponds to the full width of the wall. However, in a compound wall, in Revit it's considered that it has a core and a finish face. I'm going to show to you. Let's type WA to start drawing a wall. Then, on Properties, I click on this button to switch to a different wall type. As you can see, there are several of them here, with different widths and materials. Also, if you don't find it in this list, the type that you want, you can create it easily. I choose Render on Brick on Block. As you can see, the location line, which is Core Exterior, is at the bottom part of the core here. Visual Styles and Detail Level. To change the visual style, I click here. The current one is wireframe, which is the simplest and the one that consumes less RAM memory. I'm going to switch to consistent colors to check how it looks like. Now, the icon on the left sets the detail level. At the moment, I'm using Coarse, which is the most simple. If I click on Medium, I can see that the wall has a bit more detail. For example, now I can understand the location of the brick layer. Part 2. Here we will be focusing on manipulating walls, inserting doors and windows, as well as some important tips that can be useful during your learning process. Let's go through it. We are going to start drawing walls in the floor plan level 1, which is the ground floor. In the description of this video, I attached the link where you can download this exercise. It's going to be easier to follow this tutorial. Okay, we are going to click on the command Wall Architectural, and now I want to show you something when we draw the wall. The length dimension increments that you see on the screen depend on the zoom that we are using. For example, I zoom out and you can see that now the dimension changes with the precision of the meter. Also, unlike AutoCAD, when I click to place the wall second point, the length will be exactly what says in the label. Now let's zoom in a bit, and at this moment the values change in a range of 0.1 between each other. Zoom again, a bit more, and the values are even more closely. This time it's snapping every 0.02 meters. These settings can be edited in Snaps, located in the Manage tab. It's this icon over here. In the window that opens, the section above is exactly what I was talking about before. Dimension snaps. In length dimension snap increments, it indicates the ranges that I am using. The first value is when I am at the minimum zoom. The ranges are in the meter. At certain point, it snaps every 0.1 meters and so on. I'm going to change it in order to have just 3 ranges, and the last one 0.01. Okay, let's draw the exterior walls. I set the location line on core face exterior and draw in the clockwise direction. It's simple, I just insert the dimensions that I have on the plan. If I miss a length, like what happened here, I press Escape twice, select the wall, and simply change the dimension to the correct one, 6 meters. Then activate again the command Wall to continue. I place the first point here, then keep drawing until I reach the beginning. So I finished the exterior walls. Now, suppose I want to change the wall type to have a different thickness. The current one has a width of 140 mm. It's too thin. I have to change it to 300. I click in this option. As the location line is there, if I choose a thicker wall, the external border doesn't change. You see, the wall just goes inside. However, if I drew these walls using the core face interior, this time the location line would be there, and change the thickness, it's the internal side that keeps the same measurement. Next part, draw the interior walls. This time I chose this type with 14 centimeters of thickness. And it's not very important which wall I start, because in Revit, it's quite easy and intuitive to change the position of the walls after drawing. You will see. I start with this vertical one, because I know it intersects this corner. Then, the wall that divides the left part in 2 rooms is located at this distance of 3.8 from that external wall. One good way to make it is going to the endpoint at the corner, drag up and type the distance. Next, let's continue to draw the bathroom. Here I use the same method. Drag down, type a distance of 2.2 to to start the next wall there. Then the next is 1.13. And the vertical that comes, as I don't know the length, I place it more or less there. After I can correct it, it's not a problem. Then this one is 0.86. And the last I just connect to the external wall on the top. How to manipulate walls and dimensions. Whenever I select a wall, temporary dimension lines appear to measure the select element from the nearest perpendicular ones, usually the walls that have the same direction. Due to that, you can move the wall sideways easily. Just click and hold with the left button. At the same time, the intersect walls extend in order to not separate. However, I can't move the wall up or down due to constraints on the intersection angles there. In a situation where I have a diagonal wall intersect to the one that I want to move, in order to keep the same angle, it's becoming either longer or shorter, as you can see in this example. Another way of changing the wall position is modifying the temporary dimensions. Look what happens when I set this length to 4 meters. The dimension on the other side is also readjusted. Temporary and permanent dimensions. Temporary dimension lines only appear when I select certain elements. To make one dimension permanent, simply click on this symbol. Then click again in another place to put it there. The size of the dimension lines depend on the current scale. That's because the dimension lines in Revit are annotative. I am going to change the scale to half. It's this icon here. 150. And you can notice that the dimension lines and the wall patterns changed. Now let's learn how to change these temporary dimensions. These dots indicate the position of the dimension line. For example, in this wall, the measurement starts on this side. If I click one time, it changes to the other side. Clicking once more, it measures from the width center. Instead, if I click and hold, I can move this baseline to a different place. Now it measures the full length of this wall, here in the bathroom. To measure a specific distance, we can click on this icon, Measure between two references. It's a very simple tool to use. It snaps two lines, wall center lines or intersections. Click for placing the start point, for example from this wall, until the one in the opposite side. Here you can see the distance. Another way of drawing walls or other elements in certain position can be with the help of detail lines. Go to the Annotate tab, click on Detail Line, and I will show you an example where this can be useful. I draw a line here because I want to use its midpoint to draw a wall. I type WA to activate the command to insert a wall, then I can find the midpoint and draw a vertical wall up to the top. But, okay, if I want it to be exactly in the middle between those two walls, I press Escape once and change the wall location to centerline here, and now I'm sure it's exactly where I want it. So we can use detail lines to help us on our sketching, and when we don't need them anymore, we can simply delete them. But actually, the real purpose of detail lines is to provide extra information in your drawings. Here I'm going to use a detail line to separate different areas of a room. There are also different line styles to use that come with Revit. It's possible to edit its colors or shape and create new ones. I choose this hidden line, for example. It's a dashed green line, And suppose I want to draw it here to separate different areas of a room. Okay, this was just to show you the use of the detail lines. It's something interesting that has to be explored later in detail. But for now, let's go back to where we are. Add walls and windows to the floor plan. Revit provides a very intuitive option to insert windows and doors on the project. Those icons are located on the Architectural tab at the ribbon. I'm going to insert a door. For that, I have to place the pointer on the wall and simply click again in the place where I want to have it. If I move the pointer a bit down, the door opens to the other room. Another tip: press the spacebar to flip the opening. Now I can click. When I select a door element, it's still possible to flip by clicking on those controls over there. To change the door type, we do the same as for the walls. Click on this tab and select which one you would like to use. The doors that come with the software are named by the width and height dimensions, so this can be useful for us. I am going to choose a wider wall and look how the door is resizing from its center. Then it's normal that the distances from the corners are affected. Maybe I need to edit them again, if I consider it. To edit an element type, I select it and click on Edit Type. Here I can change the properties for this door type. For example, to change the width, just insert a different value. However, if I want to create a new type without losing this one, you can click on Duplicate, choose a name for it, then edit the parameters as you like. Aside from dimension blanks, there are analytic properties, which ones can be edited later on the project. Windows. To add a window to the project, I do exactly the same process as I want to add a door. Click on the icon. Then I hover the pointer on this external wall and click to place it. I'm going to insert more windows there. OK, now suppose that I want to change the type for some of the windows. To select several elements, I hold the button Ctrl while clicking on the windows. Then I change here to a double window type. And that's the result. Now I'm going to open a 3D view. As it doesn't appear on the project browser, I click on the View tab and go to 3D View. There are 3 types here, and I'm going to choose Default 3D View, this one. So, this is the 3D aspect of my project. I can change the view style to a more interesting one if I want. So, for example, I click in this one, Shaded. Now, going back to the windows, I select this one. And there is an important dimension in Windows we should specify, the sill height. It's the distance from the floor to the bottom of the opening. To edit it, I go to the Properties tab and change the current value to the one that I want. Now, if I look at the drawing, you can see the window moving up. Let's go back to the floor plan level 1. Suppose I want to change the sill height for all the windows in one time, and I will take the opportunity to show you a useful trick here. I select all the elements in the floor plan. I go to this tab, and here I can switch to the type of element that I want to show its properties. I choose Windows. Basically, if I change the sill height, it applies to all of the windows. height of the walls. When we turn on the command wall, we can edit some of its properties at this panel. One of them is the wall height. The walls that I draw now will be set up with a height of 8 meters. By the way, I can only choose a value here because in this tab it says unconnected. However, instead of unconnected, I can specify that the wall will connect to a specific level. In this drawing, I want to connect to level 2. Then I'm going to open an elevation tab. It doesn't matter which one, I click on East. And here you can see the positions of each level in this project. The ones below level 1 are the levels for foundations, and they are below the surface. The level 2 is located at 3 meters above the surface. Now the walls that I have drawn before, as I haven't edited the height, they measure 8 meters and they don't connect to anything. If I select them, you can notice it here. But how to change this? Actually, it's quite easy. To make sure I don't miss any wall, I prefer to switch to the level 1 tab again. Select all the floor plan, and here I switch to walls. Right away, I'm going to change the top constraint here to up to level 2. Finally, going back to the elevation plan, you can see now the difference. Okay, you could now ask, if later I decide that I want to change the level of the floor above, how can I do it? Don't worry, it's easy. Click on the level and change the elevation to the one that you want. For example, 2.8 meters. The walls that connect to level 2 automatically update. Another thing, it's also possible to change the names of the levels. For example, I'm going to rename the level 1 to ground floor and level 2 to first floor.
Part 3. Levels. In this chapter, I will get deeper into levels. As you learned previously, each level defines a vertical height or story within a building. You may also notice, when you start a new project, it comes with some levels defined by default. For example, a construction template has level 0, level 1, and levels for the foundation plans. In an architectural template, on the other hand, the foundation plans are not included, because usually they are not necessary for architects. Anyway, all these levels can be edited according to your preferences. So, let's go back to the file that I am conducting this tutorial. These are my current levels. You can see that both the first and ground floors have the symbol in blue color. This means that there are floor plans associated with those levels. The levels behind the surface have this symbol in black, because I don't have floor plans for them. Actually, I have deleted them before. Remember that you can check out the plans looking at the project browser. There is also a site plan here, but that's a different thing. That's just a plan to indicate the location of your project. How can we make a plan view for a specific level? For example, top of footing. I'm going to the View tab, then on the panel Create, I click on Plan View and choose Floor Plan. In this window, I select the floor plan that I want to generate. I click on TO Footing. Here it is. A tab has also opened for the plan. On the elevation view, you can see that it turned to blue and the new floor plan is on the project browser. At the same time, it's possible to select more than one level, and they will be generated at the same time. Now let's learn to create a new level. On the Architecture tab, I'm going to click on this icon, Level. I want to draw a new level above the first floor. It will be the second floor. In my opinion, the best way is dragging the pointer to the opposite side of the level symbol, and when the endpoint is highlighted, drag up and you can see this vertical tracking line. And it's currently measuring the distance from the first floor. I will type 3 for placing the level 3 meters above level 1. Then I go to the other side and hover this point in order to be in line with the other levels. Have a look to the options bar. And yes, I suggest you to pay attention to it always when you use a tool for the first time. The option Make Plan View is ticked. It means that a floor plan for this level will be generated, as well as the ceiling plan. Click on Modify to exit this operation. To modify the level heights, I already showed to you. It works the same way as for other elements like walls. Click on the one you want to move, and then change the lengths of the temporary dimension lines that appear. Now let's have a bit of practice. If you want, you can use this image. I attached it in the description of this video to make this short exercise. So first, I'm going to select all these levels under the ground floor and delete them. There is a warning here saying that 3 views will be deleted. Yes, the plan views for each of these levels. Except the base of foundation that doesn't have a view plan. And now I'm going to add a new level. Click on the icon. I hover this endpoint, drag down, and place the new level at 0.3 meters. Remember that in Revit, the distances that show in the drawing are precised, unlike in AutoCAD. So I can click, then move to the right, and click again on the other side. Great. Then I repeat the process for the other levels. I have to hover again the same endpoint, and this time I need to type 3.7, not 4, because the distance here is from the last level that I created. Yes, sometimes we need to do some calculations. After drawing them all, I can see that some of the level names are above others, and this is due to the narrow spacing between them, making it hard to see. But don't get stressed, this is easy to fix. And that's exactly what we are going to see now. I'm going to click on one of the levels and zoom in a little bit. You can notice this tiny jog here. I click on it, and the annotation leader is discontinued, creating those 2 grips over here. So I can use them to reposition the annotation of this level in the way that I want. I showed to you the location of the jog in the first floor level, because if I click on level 8, I hardly could notice it if I didn't know it was there. So I move this grip to the left and the one below here to not overlap the text above. Then I want to reposition all these level annotations, and don't worry because the level height doesn't change. If I prefer to have the leaders vertical, the grip also snaps to that position. Look, it's simple. Then I rename all the levels. I just need to click on its name to change it. And for the last one, the base of foundations, I don't need any plan views. So I'm going to delete the view on floor plans, on ceiling plans, and also there is one here on structural plans. Do you see? When all the views are deleted, the color changes to black. Floors. Let's go back to the floor plan, the ground floor. Now the next element I'm going to add is the floor. If you go with the mouse there, you can see there is more than one option, and I'm going to use floor architectural. Now pay attention to this. Unlike the elements that I showed you previously in this tutorial, walls, doors or windows, floors open in the sketch mode. And the same situation happens with stairs, railings or other elements. the main characteristic of the sketch mode is these controls here. The tick to confirm and the cross to cancel and discard changes. It's the only way to get out of these kind of elements. It simply doesn't work with pressing enter and escape, so you should memorize this. But okay, it's completely normal that you try to press escape, enter, without success, and you just realize it later. But let's proceed. To draw a floor, it uses by default the boundary line, and to make it, I can use a line, rectangle, arc, among other geometries, or this last one, which is currently the selected one, called Pick Walls. I'm going to choose it, and you will see that it's actually very simple. I only need to click on the walls until I reach a close boundary. I click in all my exterior walls. Notice also on the options bar that it's marked Extend into wall to core. This means that the full core is inside the boundary. However, if there was a finish face, it wouldn't be included. When I finish, I click on the tick to place the floor and exit the sketch mode. Now, as usual, it's time for learning some tips. Let's have a look at the floor appearance. I switch to the 3D view and here you have it, looking quite interesting. I can select the floor without big problems. And you can see the properties of the floor at the left. Notice that it has a specific thickness. And the elevation at top is 0 meters because it's located exactly in the same level as the ground floor. The elevation at base is negative, minus 0.15, as it's generated automatically under the ground level. So this is a generic floor with 15 centimeters of thickness, as you can see the tab on the top of the properties list. Of course, I could edit the characteristics of the floor going to Edit Type. But for now I skip this step. How to select the floor when I am at a floor plan. Trying to click directly on the walls doesn't work, but there is a way. First, you must place the pointer at the floor boundary, for example here. Now, instead of clicking, I press the button Tab to switch to the overlapped items. This is a very important tip to know in Revit, and most of the beginners don't know it. Now it says chain of walls or lines, so it's not this. I press tab again. Aha, now it says floor, so it's this one. I select it. Then to edit the floor, I double click on it to return to the sketch mode. Or I could click with the mouse on Edit Boundary. Here I can easily modify the size of the floor by manipulating the boundary lines. Now, let's add the floor also to the first floor. It's easy. I switch to the first floor tab and everything that is shown here are the walls and elements from the floor below. And that's why they look transparent. If I open a selection area covering everything, nothing goes onto the selection. On the other hand, this can be very useful to draw elements in this floor, like the floor itself. So let's add the floor. This time I'm going to choose a line as my drafting method. What I need is just clicking in all the corners until I reach back the start point. I personally prefer to use Pick Walls, but it's also fine with the line tool, as you can see. When I finish, I click on the green tick to place the floor. But look at this information shown here, it's important. Would you like walls that go up to this floor level to attach its bottom? Since the floor is generated below the current level height, if I answer yes to that question, the walls on the ground floor will shrink in order to attach the bottom of the floor. Click on yes, and then, if I want to see how they look like, I can switch to the 3D view. Now I realize the properties panel is not shown. I might have closed it accidentally, but it's fine. If this happens to you, you can open it back by just clicking with the right button on a blank space and then choose Properties. Here you have it. Then just drag it to place on the position that you want. Now let's have a different situation. To connect the ground floor plan to the first floor, we need stairs. Of course, we are not going to jump. Although, before explaining how to create the stairs, I want to teach you how to trim a section of a floor. It can be this space, the space where we will put the stairs. So, make sure we are on the first floor, then double-click to edit the boundary, and make a new boundary line here. Basically, this is how it works. If you create a boundary area inside an existing one, the floor will be just the area between both boundaries. Then, click on the tick to confirm, and you can switch to the 3D tab to check this out. It's interesting, look. If I want, I can also edit the floor boundary here at the 3D view. But it's a bit hard. It's better if you do it always in the floor plan, at least for most of the cases. Now this is important. When creating the boundary for that space, we shouldn't leave the walls without floor, because you will get the following message. Highlighted walls are attached but miss the highlighted targets. Basically, the appearance would be this. The walls don't connect with the floor, which doesn't make a lot of sense. So remember to draw the boundary how I showed previously. Ceilings. Another key elements that we need on a building are ceilings. Remember that we use them to host certain elements, where the most common ones, especially in apartments, are light fittings. To create a ceiling, we click on this button at the Architecture tab, then we are faced by two options, Automatic Ceiling and Sketch Ceiling. Automatic Ceiling is the option selected by default, and it simply works by dragging the pointer over an enclosed area, then a red boundary shows up, and that's the moment to place the ceiling by just clicking once. Okay, nothing seems to have changed. It says here, none of the elements are visible in the floor plan. Actually, ceilings are not displayed on floor plans, and for that reason we have a section on the project browser for ceiling plans. And now you can notice the ceiling on the top left room. It's displayed here with the grid. However, it's possible that when you try, you don't see anything here, because if I click on the type, some of the ceilings display a grid, but that's not the case for generic and plain ceiling, and generic is usually the option by default. Let's add ceilings to other two rooms. For example, this one and a small one at the left. To exit a command, simply press escape. Then, if I want to select the ceiling, it's the same way as selecting a floor. If I just click here in the lines, it doesn't work. I only select the grid lines instead the full ceiling. These grid lines are useful to place elements on the ceiling, for example lights, but that's something we will focus later. Now, to select the ceiling, place the pointer on a boundary line, then press tab several times until you find it. Then click. Now, to select the other two, I can repeat the same process, holding Ctrl when I click to select the ceiling, or click with the right button on the selected ceiling, go to Select All Instances to basically pick all the similar elements. And of course, this works for any kind of elements. It's a very important tip to know. As in this situation, all the ceilings are in the current view, I click on the first option. Now the three ceilings are selected. Warnings. If there is a ceiling and we place another one on the same place, I get this warning message. There are identical instances in the same place. This results in double counting in schedules. And this is not what we want, so we have to be careful. We should press Ctrl Z when this happens to undo the last action. But suppose a situation that we put a plain ceiling before and we don't remember. Then, if I add a ceiling of a different type, I don't get any message, but both ceilings are still overlapped. For this reason, I recommend, at least when we are new to Revit, to create ceilings with grids. And we will not have this kind of problems. Now, let's learn how to host lights in a ceiling. Lights are considered components. So first, we should understand what a component is. In Revit, components are used to the model building elements, host elements, and they are usually installed on site. For example, doors and windows are hosted by walls. Lighting is usually hosted by ceilings. Furniture is hosted by a floor, and so on. Then, on the Architecture tab, some components such as door or windows have its own command. However, for lights, furniture, plumbing, or other kind of equipment, there is no command for them. And to insert those elements, we have to click on the command component, place a component. So let's insert the lights. I go to this list at the properties, but when you do it the first time, you realize you can't find them, because it's necessary to load them from the family libraries. Click on this icon, load family. And now this is important. It's highly recommendable to download the family libraries if you haven't installed them on your computer. I added the link at the description of this video. Click there to access the Autodesk website where you can find the libraries. First, click on your Revit version, search for your language or country, and then install it. They are grouped by languages, countries, or even if they use metrical or imperial units. But make sure you click on a library.x file, like this one, and you will have a very completed library. Now, back to our lovely Revit. You have to choose the destination folder when you install the libraries, but by default they are located in Disk C, Program Data, Autodesk, RVT 2020 for the 2020 version, and Libraries. And to access the libraries easier for next time, you can pick and drag the folder to the standard folder section. Of course, in my case I don't want it because I already have it there. I can click with the right button and remove it. Then, to search for a specific family, in this case I want lighting, click on the country folder, lighting, architectural, then choose the family that you are looking for. I'm going to choose this one, flat round. Click on open, and then I can easily place it on the ceiling, and the grid helps me to align all the lights. Actually, there are too many snap points here, but if I zoom in just a bit, I can place it right in the intersection. Then I do the same for the others. Okay, it's important that we draw everything with precision here in Revit. Sections. Sections are not included in the default templates when we start a new project. I have to create them, but it's actually very simple. To insert a section, I can go to the View tab and click on the icon there. Is finding that icon on the Quick Access bar. To create a section, I need to insert 2 points. I click here, and then put the second one on the other side. And note that sections not necessarily have to be horizontal or vertical. It's also possible to make a diagonal one. But for now, let's just leave it simple and logical. I mean, for this situation, of course. This rectangle with the dash border is my view area, which can be controlled in this grip. In this icon at the left, I can switch my view direction. Also, this new section is generated at the project browser. I'm going to open the new section view, and here you have it. Also, notice the ceiling with the lights at the left room. Going back, now suppose I want to decrease the view area in a way that it doesn't cover the door. You can see the difference. The door is not showing up anymore. Part 4. In this part 4, we are going to focus on the Modify tab and more specifically, the commands in the Modify panel. And remember that you can always check the list of contents in the description of the video if you want to go directly to a specific part. So it's time to start. First of all, I will make an introduction about the modifying tools. They are very important in Revit. If you are familiar with AutoCAD, you can guess that some of these tools are the same. However, sometimes they look the same but work a bit different here in Revit. Command Copy. I can create a duplication of one or more elements to place in different positions. I'm going to copy the ceiling light to another intersection of the grid. Click on the icon. I can also use the shortcut CO. Select the object. Press Enter and pick up the Move Start Point. I click exactly on the center and then click again on this new position. Now I'm going to repeat the process, and you can see that sometimes the snap points change, depending on the place that you want to click. If I click right now, the new light will be exactly in this intersection. But if I want to place it in line of my selected element, you can see that it's not snapping to this intersection where I have the pointer, only to a nearest point of the horizontal line. Actually, is the only one highlighted. But there is a way here to change the snap points by pressing the button tab. Sometimes I need to press more than once to find the snap point that I want. It's this one. I'm sure it snaps to the intersection because you can notice the dashed lines and the vertical line highlighted. So click to put it there. Now let's use the command move. It's like copy but without keeping the original objects. I click on the icon, select these two lights, press Enter, choose this base point, and then move them to this intersection. The array command, it multiplies one or several objects the number of times that I want. Click on the icon, then I'm going to select these three lights, press Enter, click in the center of one of the lights, and then move up and look at the options bar. Here we can choose if we want a polar or a linear array. I want linear. And let's say I want to set the number of items as 4. Also in this section that says Move To, if I choose second, the point where I click will be the second row. So I can click in this point to place the array and then press Escape to exit. Rotate. Elements can be easily rotated here in Revit. I'm going to the ground floor plan, and this time let's insert a different component, a furniture object. I'm going to Load Family, search for the Furniture folder, and then insert one of the tables that I've got here. Let's put it in this room. Now, to use the command Rotate, I click on the icon, select the object to rotate, press Enter, then this axis indicates the start rotation point. I click and then I'm going to rotate it in the angle that it's indicating here, for a 45-degree angle. It snaps easily when I get close to that angle. If I click now, this will be 45 degrees precise. Align. This tool, I use it quite a lot in Revit. Let's learn how it works. First example. Align the wall X with the wall Y. I click on the command. First, I need to select the line or point of alignment. It's the center line of this wall. Select the wall X, and you can see that it will move directly towards the dashed line. Now both walls are aligned. Second example. Align this furniture element towards the wall. It's a nice sofa. Oh, and it's interesting to know that I can move also elements by clicking and drag them and place where I want. If I try to put the sofa against the wall, I can't do it with 100% of precision. Although with the Align tool, do the same process as before, and this selection line is not the one I want, because the sofa would go inside the wall to match the center line. On the options bar, you can see this Prefer, and I can change the part to generate the line of alignment. This time I want it to detect the wall face. Let's try. But it still doesn't work. Don't worry, usually after changing that option the first time, it doesn't work right away. We need to press Escape and reactivate the command again, and now it works. So click on it. Also in the sofa I can choose which line I want to align. It's interesting. I choose this one. Now before going to a different command, I want to show you a tip. Let's move the wall where it was before, but this time I use the wall faces as the reference lines. Now, do you notice this lock here? By clicking on it, I create an alignment constraint. What does this mean? From now on, if I move one of the walls, the second one will follow the first in order to keep the constraint. Offset. This is how offset works in Revit. It's simple. First, I need to click on the command, of course, and then look at the options bar. It shows up the offset distance, where I can set the length that I desire. I select the object to offset, and notice this. If I select the left wall face, it offsets to the left, and if I click on the other side, it offsets to the right. Basically, if I click now, I create a copy at 0.5 meters from the wall center line. And keep in mind that this distance is between the same reference of each object, not the distance between the closest faces, which is less than 0.5. Now let's see more offset options. It's not required to copy the object, I can just move it. If I untick this box, copy, and apply the offset to the left. Okay, this was numerical offset. Graphical offset, on the other hand, is used if I want to create a parallel wall in a specific point. This time, the steps are the following. Select the object to offset. Click on the offset start point. And click again to move it to the new position. If I want to copy the same wall next to the window, I can use the endpoints above. Now let's see some specific constraints. I can't offset two walls at the same time. I need to do them separately. That thing back in AutoCAD when you offset a polyline, it doesn't work here in Revit. Another thing, not all elements are eligible to offset. From the ones that I have in this view, only the walls are possible here. Not furniture, neither doors or windows. Mirror. With the command mirror, we can draw a symmetrical element. Actually, we can select more than one, from a certain axis. Let's apply this command to the sofa below, but first I'm going to move this wall a bit down. And remember that here there was a constraint against another horizontal wall, the one at the right. But if I click on the lock, that constraint is no longer here, and I can move the wall freely. We are just going to use this wall as our mirror axis. So, there are two mirror commands, pick axis and draw axis. First, I will show you the pick axis. Select the sofa, press enter, then I need to pick the axis, and you can see that those axes are automatically generated on the elements we have here. It can be on a wall center line, or in an endpoint, or a midpoint of a door or window. I'm going to choose this wall axis, and the sofa is copied symmetrically to the other side. And note that the distance between the element and the axis is constant. The command mirror draw axis only differs in the fact that we have to draw the axis. For example, select the furniture element again, and if I go to this wall midpoint, I can draw a vertical axis here, and the object is copied against the opposite wall. Notice that the new sofa was reversed, and now they are both facing against each other. They are symmetrical. Also, we can move both sofas a bit down, as this one on the right is at the entrance. It's not good. Another tip, when we are using the command mirror, and after selecting the object and pressing enter, on the options bar, we can decide if we want to copy the element or not. If I uncheck this box, the original sofa will just disappear. We can also mirror how many elements that we want at the same time. For example, I can select these two doors, press Ctrl to click on the second, press enter, then I draw the axis here, and two new doors are now at the external wall. Split elements. Now I want to show you how we can split the wall. First, let's put this sofa next to the wall again. It's always a good opportunity to practice these commands. First, let's rotate it 180 degrees. The element was already selected. Now I have to pick the start position of rotation and turn it 180 degrees. Oh, but it looks like I moved a bit more than what I should. I can repeat rotate again, but it's not really necessary. As with the command align, I pick the wall face, which is my destination, then select this axis, and you can see the sofa aligning at the wall perfectly. Then press escape twice to exit the command. Now let's learn to split an element. I click on the command, which is this one, and in the description it says cuts an element such as a wall or line at a selected point, or removes a segment between 2 points. I can go to a wall and choose a place where to split the wall vertically, from the bottom to the top. Suppose that I want that split at 1 meter from the external wall. Notice that here I cannot type the distance. However, I can modify it later if I'm not happy with the result. Then I can exit a command or make a second split. This time let's place it at 1.5 meters from the first. Okay, this wall is now divided in 3 parts. With this operation, I can click on one of them and erase it. Now let's repeat this process because I want to show you the options bar. It's very important that you get used to look at it. I know it's not natural to beginners to notice the options bar all the time that we activate a command, but believe that it will save you a lot of time struggling, especially because most of the options there are easily understandable. Like this one, delete inner segment. If I check this box, this segment between the next 2 points disappears. Now let's see how this looks like in a 3D view, and how to cut the wall also horizontally. Ah, look how nice these sofas appear here. Okay, regarding the wall, I can select each section like on the floor plan. And even they are splitted, they are still continuous like a single element. You don't notice any difference here. Let's click on split again, go to the wall, and then find one of the splits. Now I'm going to add a horizontal split at the distance of 2.1 meters. I click now, and the area that appears here is what I actually splitted. But let's have a detailed look in a different example. Before clicking, we should notice which section is highlighted. Now is the section at the left, but if I want to split the middle section, I have to move slightly to the right. After splitting, I can select this section down here and press delete to create a passage between these two different rooms. Sometimes we have this kind of situations on our buildings. If I select the section above and go to the Properties panel, I can see here the base offset, which is set as 2.1. If I change it to 2 meters, and don't forget to click on Apply, you can notice the wall going down 10 centimeters. Split with a gap. This command acts in a very similar way. The only difference is that it creates a gap each time I split the wall. So look at the appearance of this section at a 3D view. Nice, but what is actually the length of that gap? On the options bar, when split with gap is active, there is a blank to fill the gap distance. It's curious that by default I have this strange value, which is actually 1 inch, 2.54 centimeters. Let's change it to 0.1 meter. Now try again. I'm going to trim the wall here. And look, the distance towards the wall is 0.8. If I split, you can see now the distance is 0.75. What does it mean? That the split point was actually in the middle of the gap. But which elements can be splitted? In this view, only the walls. I cannot split furniture, doors or windows. So it's the same as with the command offset that I explained before. Trim Extend Elements. This tool is a mix between trim and extend commands in AutoCAD. We use them in walls mostly. If I extend this little wall down here to connect the one above, I click first on the reference, here, and then on the wall that I want to extend. Let's try the same in another wall. Select this reference line, then extend the wall on the left, and suddenly I got a message. It says, walls overlap each other. But where? I cannot see any wall. Okay, I will help. Remember that not all elements on a specific floor are visible in a floor plan. This happens when they are above the floor level, like ceilings or that wall when we switch to the 3D view. And this is actually the one that overlaps. Back to the command. Now let's extend these 3 walls up to the external wall on that side. I click on this face as my reference and select one wall to extend. Then to extend the next, I need to select the reference again, and just after, the wall. So it's fine if I just have 3 walls, but if I would have 50, it would take a long time. For that reason, we have the trim extend command for multiple elements, which is the one located next at the right. With this, we select the reference as before, and then click on the walls one by one to extend towards the reference. Now, I want to show you how I can trim walls using the same command. Let's have the example here. There are 3 vertical walls and 1 horizontal. I want to trim these sections. For that, I'm going to use this reference line. Then I need to select a section of the wall which I want to keep, and it's indicated by this dashed line. When I click, the rest is erased. Then for the next, select again the reference and click on the section to keep. But for multiple walls, it's exactly the same way as extending walls. And this time I want to keep the segments above. Also, sometimes when I want to trim, I get messages that the elements in orange can't keep joined. It's just a warning message, and if that's what you actually want, you can click on Unjoin Elements. There is also a command to extend or trim to a corner. This is very intuitive. I click on the command, then I just select two walls and they will extend towards their intersecting point. If I try to do it here, also look that you have a preview before clicking, but in this case it's not possible to erase that part, as there are doors and windows on that external wall. I can also click on two walls that intersect, and I create a corner there. But why was the left part erased instead of the right one? Because it keeps the site that I select. Part 5. Hide isolate elements. In this chapter we are going to learn to hide and isolate elements. I'm going to switch to the 3D view in this project. What can you see here? After creating the floor for the second level, everything below is now hard to see. Here I can just view a tiny part across this gap in the middle. However, in Revit it's possible to hide the elements in some certain views. I'm going to show you. I select this floor. Then on the status bar you can see these glasses over here. This is the feature to temporarily hide and isolate objects. I click on it and then there are several options. Let's choose Hide Element and you can no longer see the floor. Nonetheless, all the other views in this project, floor plans, elevations and so on, remain unchanged. This is important. Now let's hide another element. For example, this window. I hide the element and you can see that it's also temporarily hidden and the floor still remains switched off. Notice also this blue frame around the workspace, temporary hide isolate objects. It's always there when I have temporary, hidden or isolate elements. How to isolate a category? This time I select the door and choose Hide Category. And you can notice that all the elements from the same category doors are hidden. The opposite of hide is isolate. If instead I isolate this window, that hides all the remaining objects except the window here. To turn off the temporary hide isolate, I can click on Reset Temporary Hide Isolate, and everything is shown again, including the floor. If I just want to return to the previous temporary hide isolate state, just press Ctrl Z to undo. With Isolate Category, I show on this view just a specific category of objects. This time I did it to the doors. An important information: the temporary hide isolate ceases to have effect once I save and close the file. If I come back tomorrow, all the elements that I have in this view are visible again. But is it possible to permanently hide elements in a view? Yes, have a look at this floor plan. Suppose I need a view of this floor plan that doesn't have the furniture and plumbing fixtures in the toilet. In order to not modify this view, I go to the project browser, right-click on the current view, ground floor, and select Duplicate. There are several options to duplicate views, but we will go through them later. A copy of the ground floor is created. Now I can rename the view in a way that I understand better what it represents. Let's put ground floor without furniture. I confirm it. Then I'm going to select an element, for example this table. I right-click, go to Hide in View and choose Element. What I did was hiding the table in this view permanently. If instead I choose Hide Category, all the furniture elements are hidden. As the water closet and the sink are part of a different category, plumbing fixtures, I need to repeat the process for them. And note that category is the first identity that appears when I hover an element. We will go through this later, on the next chapter. These elements are permanently hidden in this floor plan. I can save the file, open it again, and the view remains the same. And by just looking at the screen, there is no way to know that some objects are hidden in this view. But how can I check out the hidden elements? Click on the bulb at the status bar, Reveal Hidden Elements, so I can see which elements are hidden from this current view. They are displayed in red. To unhide any element or category, I select one, for example this table. With the right click, go to Unhide and choose Category. This time the option element is not available, because before I hid the category of this table. I did it for the category, so the elements are now displayed. I click on the bulb to exit Reveal Elements, and I can do the same for the toilet. Look, there is also a section element hidden here. I have hidden it previously on the ground floor view, but I can select it and hide it. Hierarchy terminology. Now let's talk a bit about the hierarchy of elements in Revit. It's important that we understand these concepts. Any element in Revit, for example, let's use as an example this window, falls into three hierarchy states: category, we mentioned it in the previous chapter, family, and type. And each time you hover any element, you can see each of them. Basically, category is the top of hierarchy, in this case is windows. M-window casement double is the family, and the size that appears here is the type, the family type. When we want to add an element from the Windows category, there are by default three families loaded in the software. You can see here M-fixed window, casement double, and double hung. A family is basically the shape of an element, how it's its general look. But of course, not all windows that exist in the world fall into these three shapes. And you can find other families included on the Revit Families library. Let's have a look. I click on Load Family, then I am going to the folder where I have the window families, and here you have. There are several kinds as well as windows for the roofs. I'm going to add this one. Then it asks to specify type. And here is when the third hierarchy term comes up. According to Autodesk, a type provides a convenient way to switch several variables of a family at once. For example, the types here differ from each other in the dimensions of the window, but in, for example, a wall, the types differ in the wall thickness and in the materials used. There are several parameters to set in a type. We will learn this later. For now, let's choose just the first type and click on OK. So, at this moment, the action to place a window is active, as you can see on the Modify tab. Let's go now to Properties. Click here to choose the element to insert, and now pay attention to the organization here, as the list is organized by families, and they always have a gray background. Under each family, you can see the types currently available. For example, the newest window family that I just inserted only has the type that I added. The window casement double has 4 types, for example. However, that's not a problem because it's easy to add a new type. Let's click in this one, then go to Edit Type, and in this window you can find several parameters to edit. It's important to know that the parameters may change according to the families or category of the elements. Now, suppose I want to change the dimensions of this type. I could change the values here, but it's not very recommendable unless you know very well what you are doing. For example, these 4 windows are all from the same type, window casement double 1200 by 1500. If I change the width, for example, all the elements that I have in the project update their size. Sometimes this is useful, but we need to be careful. Okay, going back to the triple window, I can create a new type if I press Duplicate. it basically copies all the values in these parameters. First, I'm prompted to choose the name for the new type. Let's put 1200 per 400 millimeters. Of course, this doesn't change anything, it's just a name. Then I search for the dimension section and change the width to 1.2. Yes, in this project I have the units specified as meters. That's why it shows a different unit. And the height is 0.4. Return to the list, and now you can see here two types for this family. I'm going to click on this one and place it on the exterior walls. On the next image, you can see a scheme of the hierarchy nomenclature for some window elements. Stairs. In this chapter, we are going to talk about inserting stairs into our project. I should mention that it took me quite a long time to understand how to set the dimensions for the run width and landings properly, and I'm not considering the railings, which I can also set. As all this turns to get a bit complex, I will try to compress the things as simple as I can. And of course, if someone knows any tips that I'm missing, feel free to post in the comments section. Before starting, let's put into practice what we have been learning earlier. In this 3D view, I don't think we need the levels here. They are just confusing, so let's hide them. I think you probably remember how to do this. I select them, right-click, and hide in view, the full category, just in case that I forget to select any element. Now I can create a new 3D view where I can look inside the ground floor. I'm going to duplicate this current 3D view, rename the 3D copy one to, for example, 3D ground floor inside. Just put the name that you want. So in this new view, I'm going to hide this floor, but this time I select element. Otherwise, if I choose category, the floor of the ground floor is also hidden. Then select one of the ceilings, hide the category, and there are some lights that I can hide them as well. It looks nice. Now let's create stairs. To add a stair, I click on the icon at the Architecture tab and it opens the sketch mode. Now to start making the stair rises, I need the option Run, and let's start with the default Straight Run. I click for the start point and then I can draw the stair in the direction that I want. To help me, I can use Shift to draw it vertically. And then, this is important, look at this information saying that I have 11 rises created and 5 remaining. With the current type, I need 16 rises to reach the first floor, which is the top constraint. The riser height is 19 centimeters, and even it says 190 millimeters in the name of this type, it's actually an approximate value. The rear riser height is 18.75, as you can see here. So this is important to remind. Always look at the values of the parameters because they are precise. Okay, now we can look at the settings on the options bar. The location line is at the center, and it's possible to switch here to the sides. The actual run width is set as 1 meter. Okay, now I can click to place the stair, click on the tick to finish the sketch mode, go to the 3D view, and you can now see how it looks like. In the next example, we are going to insert a stair in the L shape, but still using the straight run. I do the same as before, but this time I'm not going to draw all the rises. I leave 5 for a second run. I click, then I click in the exact location where I want to start the first rise of the second run, and the space between will be the landing. Also remember that I am using the location line in the center of the stair. Now look what happens if I choose the start of the riser here. The riser starts from the center, which is not exactly what I want. Okay, I want a second run to start a line with this line. Click, then move left to finish drawing the stair. As you may realize, I didn't specify the distances as sometimes it can be a bit hard, but it's not a problem because we can set those values after. Click on this run and you can change this distance that says 0.16 to a different value, for example 0.3. If I set 0, the gap between the two runs just disappears. But anyway, let's leave it 0.1. The stair is divided in 3 sections: a first run, a landing, and a second run. When I click in a section, and remember I'm still in the sketch mode, I can see these controls here. Let's look at them. If I click and hold the grip at the end of the run, I can increase or decrease the number of rises here. But at the same time, on the opposite side, the number of rises updates to keep the desired number, in this case 16. The controls at the sides change the run width. And the same can also be done in the parameter at the properties. When I'm ready with the stair, we need to click on the tick to exit the sketch mode. And remember that it doesn't work with just pressing enter or escape. Then I can move the stair where I want, but make sure you click around the middle, because if you click on the railing, what you do is taking out the railing from its place. But it's easy. If all the stair highlights, it means that I am able to select it all and move it to the place that I want. Example 2. First, let's delete the stair that I made before. This time I want to draw the stairs in this space, and I want them aligned with the walls here. First, select this wall, and I'm going to move it slightly to the right, just to have more room here. I will do it by redefining this distance here. Let's increase it to 2.5. Now I activate again the command to insert stairs, but this time change the location line to the right of the run. The start point, I'm going to place it here, and then I'm going to create until here, the first 9 risers. I click, then I select the start point of the next run along the left side and place it at this wall. Don't worry if the stair looks a bit deformed, because we can fix this after. Now that I don't have any remaining risers, I can click. In the sketch mode, we can still use the modify tools to each section of the stairs. Here I'm going to use the move command to the run below. I select the section. I click in this endpoint and move the run to this intersection. As you can see, it's not hard. Finally, we click on the tick to confirm the stair placement. Then if I want to align the stairs to the walls, I can use the Align tool. And if you want to know, it took me quite some time to figure this out when I was learning how to work with stairs. Anyway, I'm going to move a bit out of the wall to be easier for you to understand. I activate Align or press AL. I select this wall side as the reference of alignment and then click here, and you can see that the stairs move automatically towards the wall. Then click on the lock to constrain this movement. This means that if I move the wall, the stairs also follow to keep the alignment. Right next, I click on this wall at the top for the new reference of alignment, and then select this side. Also click on the constraint, and now you can see that I can move the walls in the direction that I want, and the stairs remain in the corner. It works for both sides. Now let's press Ctrl Z twice and change to the 3D view to have a look at the stairs. However, you can see the stairs going a bit inside the wall here. But this is something we will learn later, in another video. On the next section, we are going to draw a stair in a U-shape, and our goal is to attach it in this compartment. Using the same assembled stair, I need 16 risers to reach the next floor. So I draw the first 8. This time I'm using the location line in the center, but that's fine. Then I start the second run of risers aligned with the end of the first run. Then drag the mouse down to draw the stairs vertically in this direction. As you can see, this is a simple way to draw a stair in a U shape with the landing. This is important. With the sketch mode active, it's still possible to move the entire stair, but make sure you select it all. And as you can see, it's a bit hard to attach it to the walls by just dragging it from a random point. However, the move command is a great tool to attach each run to the wall. You will see. Click on move, select the element, press enter, choose this endpoint at a corner and move the run towards the wall. With this method, you can notice that the run width doesn't change. Then do exactly the same for the second run, and when I finish, just click in a blank space. To attach the landing, I can use the Align tool, select the reference line, then this entity to attach it to the wall. I can exit the sketch mode and I get a message that the railing is not continuous. This is common to happen when I draw a U-shaped stair. If you zoom a bit, this is the struggling point. In a 3D view, you can see better its appearance. There is a little gap here, and in the other side there is a small jump from the landing to the ramp. So, the way to solve this is increasing the landing. I am going to double click in the stair to get back to the sketch mode. Then I select the landing, and if I click and hold this little arrow, you can see that I am able to extend the landing by dragging down with the mouse, and I can either put the distance that is indicating here or type a specific value. Let's put 0.3, and with that I will have enough room. Then I go to the other side and repeat the process. Click on the tick to confirm the changes and exit the sketch mode. Now I no longer have that issue. And in the 3D view, you can see the railing being continuous and it looks also more beautiful. Now let's learn some tips. After placing the stair, there is an arrow indicating the direction to reach the upper floor. When we are in the sketch mode, we draw from the down part to up. However, if we select the stair, we can click on this little arrow to switch the direction. When we go to edit the type of stairs, there are some specific parameters just for them. The section at the top are the calculation rules. There is a maximum riser height, a minimum tread depth and a minimum run. Basically, I get a warning message when any of these parameters is not satisfied. For example, if I change the tread depth and click on apply, I get this information. However, the program still makes the change. Below, I can edit the supports that I want to the stair. If I want a stringer, a carriage, or even none. If I'm creating a stair in a slope attached to walls, for example, it's not required the stringer, so you can check none. Part 6. How to draw dimension lines. As you remember, in this tutorial we have already learned how to work with temporary dimension lines and how to make them permanent. So it's time to get a bit deeper into this topic, but let's do it gradually. Now look at this example. To insert a dimension line, I have to go to the Annotate tab, Dimensions panel, and choose one of these types. I'm going to start with the option Align. Now, if you look at the options bar, we have by default the pick option set as Entire Wall. This means we can click on a wall and place a dimension line of its entire length. So, it's simple. And remember that after, I can still readjust the position by moving the grips to different references. Now, sometimes it suits me better to add a dimension line by choosing 2 points instead. And for that,
I'm going to switch this tab to Individual References. With this, I can add a dimension line from this side of this wall up to the other extremity. Then click again on the position that I want the new dimension to be located. Let's measure now the horizontal line, and if I don't press Escape to exit a command, I keep adding dimensions as long as I want. Now I want to start from the left side, but you can notice it's highlighting the center of the wall. The reason for this is that I have the reference lines set to detect the wall center lines, instead of the wall face, which is exactly what I'm going to switch to. Now it's working as I want. To finish, let's put also a dimension to measure this vertical wall. Editing dimension lines. One important thing, it's not possible to change the length of the dimension by just double-clicking on it. Instead, it opens this window where I can edit some options. Here, I can replace the actual value with a text or add prefixes, suffixes, or text above and below. For example, I can choose to replace the value with a text. Type for example wall 1 and then click on OK to save the changes. But have in mind, if I want to cheat or just change the actual value to an approximate number, the program doesn't let me to do it. It says that I cannot replace a value with a different value. Basically, to modify the length of this wall, I have to select the wall first and then click on the dimensions in the same way that I do for the temporary ones. Notice also that when the dimension is editable, the color changes to blue. But not always is possible to change the length of a wall by simply changing the length of the permanent dimension line. If you look at the horizontal wall above, it's intersected with a wall at the left and another wall at the right corner. Suppose I want to increase the length to 8 meters. Would it extend to the right or to the left? For this reason, the dimension is not editable right now. Yet here, without a wall at the right, I select the wall, and now yes, I'm able to change the length to 8 meters. As you can see, it extends to the right, because there is no wall there. Now let's see some tips, tricks, and additional options. Entire walls, auto dimensioning options. Have a look at this floor plan. I'm going to insert another align dimension, but this time I will pick an entire wall. As you remember, if I select this wall, I can add a dimension of its total length. Now, at the options bar, there is a button called Options. Click there. Auto dimension options. Basically, I'm able to create dimension segments in an entire wall, and this is a very useful feature you are going to understand. I tick on intersecting walls and you will see what's going to happen. Click OK, select the wall, and I automatically create segments when walls are intersecting. So this is very nice. I can avoid adding dimension lines manually with this, which could take a long time for large building, for example a hospital or a hotel. Now, if I want to do the same for the wall above, just click there right away, and when I finish adding dimensions, press Escape. Don't press Enter because it doesn't work. Another option is Opening. In this case, I add segments in order to measure the distances regarding walls or doors or eventually a different kind of opening. I can choose from centers or widths. First, I'll show you the option Centers. Choose this wall that has several openings, and you can see that here I measure between the center of each door or window. If instead I choose widths, I add a dimension line with segments measuring the widths of each door and window and the distance between them. Now, suppose in this dimension line, I want to delete one of these segments. Maybe one or two of these are not necessary in my drawing. If I try to select just a part, it doesn't work by just clicking on it. You can see that I select the full dimension line.
However, there is an easy way to do this. Do you remember that we can use the button tab of the keyboard to switch between overlapping objects? That also works here. I press tab when hovering this segment, and now that it turned blue, I can click to select just this dimension and then press delete to get rid of it. Now they are two different elements. You can see that I have to select one at a time. In the next example, I'm going to create a dimension line, but this time using individual references. I pick these two reference lines. Then, to place just this dimension, I just click anywhere out of an individual reference. That's what I showed to you before. But let's repeat this. I pick the same lines, and then if I choose another reference, it adds a continuous dimension here. And of course, I can keep doing this process until I'm happy with the result. As you can see, this is also a quick way to have several dimension segments, and one big advantage here, when comparing to auto-dimensioning, is that I can choose the references by myself. Another important thing, suppose I made a mistake in the selection. I don't need to worry about that, because I can always click on a witness line, witnesses lines are these dimension extension lines, to remove it. Witness lines. I can add or remove witness lines after a dimension is placed on the screen. For that, I have to select the object, and on the ribbon there is an option here, Edit Witness Lines. Click there, and I can add a new witness line by just picking a new reference, for example the side of this door. Also, I can choose a reference inside the segment, and it will split it. Or even remove a witness line if I click on an existing one. At the end, click on an empty place to confirm the changes. And don't press escape, because it will cancel what you were doing. Constraints. When I select the dimension line, you can see these locks on each segment. At this moment, all of them are opened, meaning that these dimensions may change if I change the position of the windows or move the walls instead. Let's click on this lock. What I did was constraining the distance from the limit of the external wall and the window. Now it has a fixed value of 1.11 meters. I select this wall. You can see the indication of the constraint here down. And if I move the wall towards the right, the elements of the wall below move in order to keep this distance of 1.11 meters unchangeable. Let's set just a specific distance between the wall where my stairs are attached and the external one, instead of a random distance, for example 5. Another option in dimensioning in Revit is the dimension equality. Have a look at the wall on the right. First, I'm going to add an extra window here. I can go to the Modify tab, click on Copy, select the window, press Enter, pick this endpoint and place a new window here. Then I'm going to add a new dimension. Choose Entire Walls, and on the options I'm going to specify centers and remove the tick from intersecting walls. Click on OK. Then I add an align dimension to this wall. And now you can notice this EQ with a red slash on it. It's not very easy to see because it's quite small. If I hover it, it says Toggle Dimension Equality. Basically, if I click there, the windows are automatically moved in order to have the same value in these 3 dimensions. And even if I increase the wall, the equality always keeps. Okay, there is a question you can ask yourself. If the EQ symbol is displayed, how can we know the length of these dimensions? If you click on the dimension, then click with the right button, you can see a tick here on EQ display. If you uncheck it, the values are displayed now. However, they are still in equality constraint mode. We know that because the EQ symbol is there without the cross on it. But how can we remove a dimension equality? The answer is select the dimension and click on the EQ to remove the constraint. It's just simple as that. But what I think usually happens is people tending to select the dimension and delete it right away. Then we get this warning message. Basically, we are removing the dimension, but the elements are still constrained. This way also works, but make sure you press on Unconstrained here. More dimension styles. Linear dimensions. These are similar to line dimensions, even a bit less versatile. The way they work: I must click in 2 points to place the dimension. For example, I'm going to click on this corner. And there is actually a blue point appearing on the screen, even it's very hard to see sometimes. Then I'm going to select the point where this window starts as the second point, and finally place the dimension. But look what happens when I choose the same first point and then try to click along this line, a place that isn't a corner endpoint or intersecting point. I cannot place the dimension, as you can see. So, in the dimension that I have created, the points were located in the same x-axis. They were horizontally aligned. Now let's see a different situation. I'm going to choose the first point as the end of this wall face, and look, when the point is not easily understandable, Revit displays a bigger point. The second point, I choose it a bit up, so they are not either vertically or horizontally aligned. And finally, I can add a horizontal dimension, or if I move all the way out, I can now display the vertical distance between the points. Angular dimension. With this type, I can measure angles. Look at this example where there is a diagonal wall. I'm going to put an angle dimension there. I click on Angular. My selection mode is set to prefer wall faces. I choose this face, then this vertical one, then I just click on the position that I want to place it. After, I can keep adding more angles as I wish. Radial dimension. This time I'm going to draw a circular wall. I choose Circle in the Draw panel. Just make a random wall. Then go to Annotate. Click on Radial dimension. Then click on this face to put a radius there. The diameter dimension is very similar. It just has a double arrow indicating the diameter. And it's easy to differentiate from the radius dimension. Part 7. Roofs by footprint. In this chapter we are going to learn to draw roofs in Revit. Here we have the same floor plan, but this time it doesn't have the stairs. Imagine it as just a one-story building. We are going to draw the roof here. Let's open an elevation plan, and as you can see, we should draw the roof on the view plan called level roof. This one. That's important, because if you just try to make the roof on the ground floor view plan, the roof just goes directly to the ground, which is not exactly what we desire. So, I'm going to switch to level roof, and I realize nothing is shown here, even if I zoom in or zoom out the workspace. Basically, if that also happens to you, have a look at the underlay section on the Properties window. On the first tab, Range Base Level, I decide here which elements I can view below the current plan. It is set as Known. So I click on this tab and switch to Ground Floor. And now it's better, I can see the floor below. Now we can draw a roof. I'm going to the icon at the Architecture tab, click on the arrow below and select the first option, Roof by Footprint. On the properties, I can choose from several roof families already loaded in Revit. Let's start with the one defined by default. Also, the command Roof by Footprint opens in the sketch mode, just like floors and stairs. I'm going to choose as my method, Draw the Boundary, with Pick Walls. But first, let's look at the options. It's always important. I'm going to check this box, Define Slope, as I don't want a flat roof. However, not all the walls require a slope, but we will look into that later. Now look at this one that says Overhang. It's basically the distance from the roof start point and the wall face. If I set 0, the roof starts exactly at the walls. But in this example, I don't want that. I'm going to define an overhang of, for example, 0.3 meters, which is 30 centimeters. Now I'm going to hover one of the walls with the mouse, and you can see the boundary line located at 30 centimeters from the wall. And if I drag the pointer closer to the internal side, the boundary just switches here. So let's click where I was previously. Then I pick all the external walls, one by one. When I finish drawing the boundary, you can see that all the sides have a slope defined there, because all of them have this symbol. And the angle is the one set by default, which is 30 degrees. Click on the tick to confirm the roof. But there is a question here. Would you like to attach the highlighted walls to the roof? I'm going to say no for now. I switch to the 3D plan, and here there is, the roof looking quite nice in this house. Let's select it, and you can see that the walls remain exactly where they were before, because I answered no to that question. If I clicked on yes instead, you can see the walls going up to the top. Edit slopes on roofs. Now I'm going to remove this roof and create a new one. This time I don't want slopes in all sides, and the angle will also be smaller. Click again on Roof by Footprint, select just these 4 sides, and to connect the last and first points of the boundary line, I'm going to use this time Extend to Corner. Click on this line, and then on the first star I drew. Okay, this is the boundary of this new roof. Now let's select all the lines, but for that I must click on Modify to do it. Then on Properties, I can modify the slope angle if I wish. I'm going to set, let's say, 18 degrees, and click on Apply. So all the angles changed. Then I select these 2 sides and remove the slope. I uncheck this box. Click on the green tick to confirm the changes and choose No here. Now look at the 3D view, how the roof looks like. But of course, as you can see, it's necessary another roof in this part. So let's go again to the roof plan. I activate again Roof by Footprint. Click on these 3 walls. Then I need to switch to Draw a Line. I click on this endpoint and draw it up to this intersection. And to remove the extra part, one of the possible ways is using Trim. Select this one as the reference line, then click on the part of the line to trim that I want to erase, which is this side. Now I can modify the slope angle and notice that it will apply to all the sides when no one is selected. Next, I select the sides that I don't need a slope, remove the tick on Define Slope, and place the roof. Here again, I'm not going to attach the highlighted walls to the roof for now. Then let's go to the 3D view to have a look of the result. It looks nice, but of course, I need to join both roofs now. And this requires just a simple step. On the Modify tab, there is a specific command to join roofs. Click there. Select an edge at the end of the roof that you wish to join, click on this one, then on the surface of this main roof, and it's done. You can see they are joined, but they are still separate elements, here on Revit. Now, this gap between the external walls and the roof, it's not very nice, I know, so we have to attach them. Attach walls to roofs. I want to attach this wall to the roof above. I select it, click on Attach Top Base, and then select the roof, and the wall will extend exactly up there. Then I just do the same for the others, but I can do it by switching to the ground floor view, because it's easier to select several walls here. These below, I leave for after because they will attach to the smaller roof. I click on Attach, then I switch to the 3D view and click on the roof. Tcharan! Done! Finally, I just need these two walls and they are going to connect to this little roof here. Now we are going to speak about grids. They are useful for setting a specific position of certain elements in a project. For example, one of the most common is using grids in floor plans for placing columns. In Revit, the way we draw grids is very similar to levels. To draw a grid, we click on its icon at the Architecture tab. Then click anywhere for the first point of the grid, it can be here, and then click again for the second point. And notice that the bubble by default is displayed on the second point. Now it says 2, but I want this identification to be 1. This happened because I already placed the grid before. Click in the number and change to the one that you want. The squares at the extremities of the grid line indicate if we want a bubble or not. If I uncheck that box, the bubble just hides. On the other hand, if I go to this side, I click here to put a second bubble. Then I can continue adding more grid lines, and if I move the pointer to this area, I can see a tracking line to snap the first point along the same horizontal axis. I can also type a specific length of this temporary dimension that is appearing here. However, if I just want a grid to overlap the wall face, you can click when the distance is 0 or in the end point, then drag to the other side and click exactly at this point. As you can see, this bubble is automatically labeled as 2. Now drag the grip down here to put it in line with the previous one. So I place 2 more vertical grids in this view by just repeating the same steps. Great. Now let's start adding horizontal grid lines. Okay, the first one, as I want to overlap this wall face, I can click in this endpoint, as now it's hard to snap to the wall in a different position. Then notice that the grid numbering keeps counting on the same way, as the last was 4, now it says 5. However, we usually don't want to have the same counting system as for the horizontal grid lines. We can have letters here, and the next grid lines will follow an alphabetical order. Now let's put 2 more grid lines in a horizontal direction. When I finish, I can edit the grid lines as I like. We can do that by clicking and dragging the grips on both sides, and you can see that they come all together. Revit by default puts a constraint on the movement when you place the start and end point along other grid lines, and you can see this lock symbol on both sides. I'm going to click on grid number 2, and if I unlock this grip, we can extend just this line freely. After placing the grid lines, we can easily change their position. If we click on one of them and modify the temporary dimensions, it works just exactly the same way as for the walls. Let's now insert some columns in Revit. You will see that it's very practical to do this here, especially when we use grid lines. I'm going to start with the architectural column, which you can find in the Architecture tab. Select the architectural option first. Then we have one family already loaded with 3 types. Of course, you can find out more families on your libraries, some with more interesting shapes. But in this tutorial, one of these suits perfectly. Let's use this first one. Now we assume the grids have the purpose to place the columns. That's easy, because columns snap automatically to their intersections. So I'm going to place one column at each intersection, inside the building of course, and at the end just press Escape twice. At this point, columns and grids act together. If I decide that they are not placed correctly, I can easily change the grid position, and you can see that the columns always stay in their intersections. Now let's look at the Options tab. Here you can choose the top constraint. At this moment the columns are set to reach the level roof, and they are going up from this floor, because this option is set to height. Then, rotate after placement. If I check this option, I place the columns and then set a rotation angle. The option Room Bounding only works when we have room elements in the project. I haven't introduced rooms yet in this tutorial, but I can let you know that when room bounding is checked, the columns don't count to the room area. But don't worry, we will get deeper on that later in this course. Let's insert a structural column. As you can see, it works the same way. The main difference is that these columns go down by default from the current plan. This option is set as depth to the top of foundation. We can notice this if we switch to an elevation view. Look, our structural column appearing over here. Due to that reason, we may have a problem on the visibility when we insert a structural column. None of the created elements are visible in the floor plan. Of course, they are going down, and I'm not seeing anything below the ground floor. Do you remember how to solve this? Okay, just exit the command column and then on the floor plan properties, change the range base level to top of foundation wall. Then click on Apply and you will be able to view the elements below. Good. Now, how can we very quickly add a structural column in each architectural column? On this panel, we can add multiple elements. We can place a structural column at grid intersections or at the architectural columns. I don't want a column at each grid, so better choose architectural column. Then I select the elements. I can choose one by one, or to be quicker, just open a selection window to cover them all. Simple. Then click on this tick to confirm the changes. As a conclusion, this is very intuitive for an engineer that needs to make the structural project using plans from the architecture. It's easy to change the position of the grids or even add or remove columns if necessary. So, it's all for now. Thank you very much for watching and subscribe to CAD in Black to receive notifications of new updates. There are Revit and AutoCAD tutorials, but in the future, maybe you will find some more. Alright, keep in touch and see you next time.